Why are there so many types of screw heads? Hello, engineering enthusiasts. Today, we're going to dive into a detail that seems small but hides a huge amount of engineering and a very well-defined purpose behind each design. Screw heads. You know that feeling when you grab the wrong screwdriver or try to fit a Phillips head screwdriver and it just doesn't get the job done, slipping and stripping the screw? Have you ever stopped to wonder why, with so much technology, they still haven't invented a type of screw head that works for everything? Why do we need so many options? Slotted Phillips, hex, Torx, Pozidriv, and so on. To begin with, why isn't there a universal screw that solves all our problems? The answer lies in the old engineering saying, there is no perfect solution for every problem. Each type of screw head was developed to meet a specific need, optimizing some important aspect, such as force transmission, assembly speed, safety, or manufacturing cost. It's a matter of balancing several factors. Think of it like tools. You don't use a hammer to tighten a screw, right? Each tool has its own function and it's no different with screws. So what are the factors that lead to the creation of so many types of screw heads? Basically, necessity drives engineering. One of the main ones is torque transmission. The ability to apply force to turn the screw without the tool slipping or damaging the head is essential. Another critical point is assembly efficiency. On production lines, every second counts, and the ease of fitting the tool and the resistance to the tool slipping out of the slot are crucial. The manufacturing cost also matters, since screws are mass-produced and every cent saved makes a difference. In addition, safety, appearance, the durability of the assembly, and even compatibility with automation are important considerations. Let's explore some of the most common types to understand how these principles apply. Who hasn't tried to loosen a screw with the wrong wrench, forced it, slipped and stripped everything? Then we learn the hard way. It's not about pushing harder, it's about using the right fit. But let's go. Let's start with the oldest and maybe the simplest one, the flathead. But what makes it so common despite its limitations? Its simplicity is at the same time its greatest advantage and its greatest disadvantage. The slotted head is essentially a straight notch at the top of the screw. This makes its manufacturing incredibly cheap and easy. Historically, it was the easiest type to mass produce and to tighten with rudimentary tools like a coin or the tip of a knife in an emergency situation. However, the big weakness of the slot is its inefficiency in transmitting torque. The force you apply isn't distributed evenly and the tool tends to slip out of the notch, a phenomenon known as come out, especially if you don't apply constant pressure. This can damage both the screw head, making it impossible to tighten or loosen, and the tip of the tool. Furthermore, using electric screwdrivers with slotted screws is a challenge, as the risk of come out is very high, reducing both the speed and safety of assembly. For these reasons, today the slotted screw is used in low torque applications where aesthetics are important, or in simpler wood screws, where cost is a determining factor. If the slotted screw had so many problems, how did the industry solve this on the production line, especially with the rise of car manufacturers? The answer came with the Phillips head, patented by Henry F. Phillips in 1936 and popularized by General Motors. The Phillips head revolutionized industrial assembly because its cruciform design, with 4 slots meeting at the center, allowed for better alignment of the tool with the screw. This meant that the operator could fit the tool faster and more easily, even when using electric screwdrivers. But here comes the most interesting and often misunderstood detail. The Phillips head was designed to have come out. That's right. It was intentionally created so that the tool would slip or cam out of the slot when a certain amount of torque was applied. But why do that on purpose? On an assembly line, it's crucial to avoid over-tightening, which could damage parts or the screw itself. The come-out of Phillips served as a torque limiter at a time when screwdrivers didn't have precise electronic torque control. This protected the parts, sped up the process, and prevented the operator from applying too much force. However, for home use, this feature is the one that causes the most frustration because we are used to tightening all the way, damaging the screw head. The Phillips was good, but it still wasn't perfect for every situation. There was an evolution to improve grip and torque transmission without losing the ease of use on assembly lines. Yes, and the result was the Pozidriv head, a European patent that emerged as an evolution of the Phillips. If you look closely, you'll notice that in addition to the 4 main Phillips slots, the Pozidriv has 4 smaller radial marks, offset between the larger slots. These small additional ribs increase the contact area between the tool and the screw, resulting in better grip and the reduction of the cam-out effect, allowing more torque to be applied before slipping. The main advantage of the Pozidriv is its ability to transmit torque more efficiently than the Phillips, without requiring as much axial pressure from the operator. This means less fatigue and less chance of damaging the screw head. It's very common to confuse Phillips with Pozidriv. And using a Phillips screwdriver on a Pozidriv screw is not ideal because you won't get a perfect fit and you'll still have problems with cam-out. Pozidriv is widely used in Europe and in applications that require more robust and repetitive tightening. And if we want to apply much more force without the screwdriver slipping and still have a compact design, what's the solution for that? Especially in machines and furniture. The internal hex head, popularly known as Allen, which is a famous brand of hex keys, is the answer. With a hexagonal recess, it offers 6 points of contact for the tool. This geometry allows for much higher torque transmission without slipping out, as long as the key is properly fitted. Its advantage is the efficiency in force transmission and the durability of the fit. And that's what makes it ideal for assembling equipment, bicycles, furniture, and machines where the tightening needs to be firm and the space for the tool may be limited. The Allen key is compact and allows you to access screws in hard-to-reach places. The downside is that if the screw is over-tightened or if the key isn't fully inserted, the hex can strip or round off the outer edges, making it difficult to remove. Speaking of high torque, what other option has emerged to further optimize force transfer and extend the lifespan of the tool and the screw? The Torx or star head is a brilliant example. Created in 1967, its 6-pointed star shape with straight and rounded sides provides a much larger contact area between the tool and the screw compared to Phillips or hexagonal. The Torx practically eliminates cam-out, allowing the application of significantly higher torque without damaging the screw head or the tool. This results in higher assembly speed on automated production lines, longer tool and screw life, and less fatigue for the operator. It is widely used in the automotive industry, in electronics, and in any application where fastening reliability and assembly efficiency are critical. The disadvantage is that, just like the Pozidriv, it requires a specific tool. And is there any screw head that is particularly robust, good for hand use, and that has a solid fit, especially in situations where the screw needs to stay on the tip of the tool? That's the Robertson head, or square drive, which is very popular in Canada, where it was invented by P.L. Robertson in 1908. Its square recess provides excellent grip and much greater resistance to cam out than the slotted or Phillips heads. One of the great advantages of the Robertson is that the screw tends to stay on the tip of the driver, allowing the user to use just one hand to position and tighten the screw, which is extremely useful in woodworking and construction. It's a robust design and less likely to damage the fitting. Although it's not as widespread globally as Phillips or Torx, its efficiency and durability are highly appreciated in various applications. But what if the goal is precisely to prevent someone from unscrewing something easily? How did engineering solve this challenge, especially in electronic products or items in public spaces? For this situation, the security screws, or tamper-resistant screws, were created. They are designed to be difficult or impossible to remove with common tools. There are several types: one-way screws, which tighten in one direction but can be loosened in the other; Torx with a central pin, or Torx tamper-resistant; three-wing with 3 wings; spanner with 2 holes; or pentalobe with 5 rounded points, which are famous in Apple devices. The purpose of these screws is to discourage tampering, alteration, or theft, ensuring the integrity of equipment or the security of installations. Each one requires a specific tool, which is often hard to find, fulfilling its protective function. The diversity of screw heads is not a failure of standardization, but rather a testament to engineering's ability to adapt solutions to specific problems. Each design is a compromise, an optimization for a particular set of requirements. Whether it's assembly speed in a factory, maximum torque transmission in an engine, durability in a component that will be tightened and loosened multiple times, or temper resistance. If you've made it this far and enjoyed the video, make sure to subscribe if you haven't already, leave your like, and turn on the notification bell. And if you find our content interesting, consider becoming a member to help us keep producing content here on the platform and be mentioned in our videos. And if you're curious to learn more about the courses we recommend, scan the QR code here on the side or check the link in the video description to gain access to various opportunities to develop several skills that will make a difference in your career. And you, what type of screw do you come across most often in your daily life? Have you ever gotten frustrated with any specific one? Leave it here in the comments because I want to know. Right here on the side, there are 2 interesting video options that you need to watch to expand your knowledge and explore your curiosity. And if you want to support us, leave your like, subscribe to the channel, turn on the bell, and consider becoming a channel member. That's it, engineering lovers. A big hug, and I'll see you in the next video.